Example 5, sampling distribution of the sample range. As in the previous example, consider the samples of size n equals 2, randomly selected from the population of 4, 5, and 9. So find the population range of 4, 5, and 9. Well, the population range would take the value of the maximum and subtract the value of the minimum. So 9 minus 4 is going to equal 5. Now, in a table, we want to list the different possible samples along with the probability of each sample. Then summarize the table in the probability distribution. So, if we take a look at the first sample is going to be 4, 4. So, if we take 4 and subtract 4, it's going to give us 0, and the probability of 0 is 1 out of 9. The next sample is going to be 4 and 5. So if we take 5 minus 4 to find the range, and that equals 1. Therefore, the probability of that is 1 out of 9. The next sample is 4 and 9. So if we take 9 minus 4, that gives us 5. And we have a probability of 1 out of 9 for that. The next one is 5 and 4. If we take 5 and subtract 4, that gives us 1. So therefore, we get 1 out of 9. And then next we have 5 and 5. If we take 5 minus 5, that gives us 0, and therefore that's 1 out of 9. And then we have 5 and 9. So if we take 9 minus 5, that gives us 4, and therefore that's 1 out of 9. If we have 9 and 4, 9 minus 4 gives us 5, and therefore that's 1 out of 9. 9 and 5, 9 minus 5 gives us 4, so we have 1 out of 9. And then 9 and 9 is 9 minus 0, which gives us 1 out of 9. So, first thing is first, let's take a look at when we get the range of 0, and how many do we get of those. We have 1, we have 2, and then we have 3. So 1/9 plus 1/9 plus 1/9 is going to give us a total of 3/9, which reduces to 1/9. The next range we get is 1. We have 1, 2, so we have 1/9 plus 1/9, which gives us a total of 2/9. Next value is 4. So we have 1, 2, so 1/9 plus 1/9 gives us 2/9. So that should be 2/9. And then the last one, we have 5. So we have 1, and then we have 2, so that's 2/9. So that represents 2/9. So there is our table. Okay, now based on the results, we want to find the mean of the sample ranges, and do the sample ranges target the population range. So what that means is we got to add up all of these values and then divide those by 9. So if we take 0 plus 1 plus 5 plus 1 plus 0 plus 4 plus 5 plus 4 plus 0 and divide that by 9, we get 20 divided by 9, which gives us 2.222. Rounding it to 2 decimal places gives us 2.22. So now, what do these results indicate about the sample range as an estimator of the population range? Well, because the sample ranges do not target the population range, the sample range is a biased estimator of the population range, because if we look at the mean of the sample ranges, we get 2.2. If we come back here, the population was 5, so we can see that 5 does not equal 2.2. So the interpretation would be the following. Because the sample range is a biased estimator of the population range, a sample range should generally not be used to estimate the value of the population range.